Okay, Algebra 2, Lesson 6.7. We've got word problems, but here's some real good news. You're going to be able to use Desmos to help you solve. In fact, Desmos will do all the heavy lifting for you. You're going to have a box, and I'm going to go ahead and draw a quick box here just so that we can have a visual. And as you look at this, it says the width is 2 times the height. Let's just say I don't know what the height is. I'm going to say the height is x. The width is going to be 2 times the height, so that's 2x. The length is 5 more, 5 plus that height. So the volume, they tell us, is 87. So here's what I want us to really take a look at here. This width is 2x, but the length is 5 plus x. If I wanted to come up with a volume equation, volume is always length times width times height. And the length is 5 plus x, the width is 2x, and the height is an x. So that's my volume. But I'm also going to be told that my volume is 87. So I'm going to graph both of these and find where I get intersection. So hopefully this is going to play out well as we're working this out. So I'm just going to go to Desmos right now and go to my y equals. And first I'm going to write a general formula. I'll say, well, I had my 5 plus x. That was my length. Now I'll say parentheses, my width was 2x, and my height, I'll even have another set of parentheses. That's right there. And then I'm going to have y equals 87. And guys, at that point, I'm going to be interested in seeing where I get a crossing. So I'm going to zoom out. And by the way, some kids like to zoom out a little differently. They like to actually click and drag upwards. But you can see this blue line is y equals 87. When I click right here, I'll get x is equal to 2.42, and my y is 87. So they're interested in knowing what the height is, what x is. We just found it when we graphed. We had x is equal to 2.42, and we are done. 2.42 feet. Look at that. All right, so let's move on to example 2. We've got a rectangular box that has length by width by height. That's 4 by 4 by 5. Increasing each dimension by the same amount. So here's what's going to happen. I've got my old box right here, which is 4 by 4 by 5. And I've got a new box that just got bigger. And here's 4 plus x, 4 plus x, and 5 plus x. I added some unknown amount to make each dimension get bigger. Now, my volume right here is simply 4 times 4 times 5. And you could take your calculator out real quickly and do that. 4 times 4 times 5. Of course, 4 times 5 is 20. 20 times 4, you'd get 80. So this volume is 80. The new volume, well, let's see here. I'm going to call that y. It's length times width times height. But it's going to be 4 times the old box. Look, if you've got 80, 80 times 4 is 320. My new volume is way, way bigger. It's 320. 4 times 8 is 32. Just put a 0 on it. So tell you what we're going to do. We'll just go back to Desmos. And you could even clear all this out if you want. And say, well, I need a 4 plus x. Close my parentheses. I'll have another 4 plus x. And then we'll have a 5 plus x. But wow, tell you what, my volume, and that's what y is going all the way up to 320. Now, I'd already zoomed out, so I'll, just hit the home button. That home button at the bottom can always help you out. But now this lowest button is zoom out, and we can keep zooming out. And the problem is, as you're looking here, it will only take you a moment to click. You can see it's 2.52. Just look at that x value. That's what x is. That's what was added to each of the sides to get a volume of 320. So my x value is 2.52. And that's what they're trying to ask here, 2.52 feet. They want to know how much each dimension was increased. You'd answer that. One last one. So we've got a cube. We've got a cube here, and that's an x by x by x. It's a 3-dimensional square, of course. But they're saying a 5-foot slice is cut out. So here's a 5-foot slice, and you could just imagine it's like somebody took a knife and just removed all of this in yellow. And we're going to be left with a box. It's no longer a cube. You can ask yourself, what's changed? Well, this used to be x, but we just lost this 5. Your new height will only be x minus 5. See, it's a shorter box right now. You lost that slice. And the volume's going to be 129. So my volume is length times width times height. My new height now is just x minus 5. But my volume is 129. And they want us to find the length of the original cube. That's x. X is the length, the width, and the height. So let's go back over here, and we can very quickly just delete this and say, well, we've got an x, we've got another x, and then this one was x minus 5. We lost 5 feet. But the volume that they tell us is 129. So tell you what, I'm going to click this home button on the bottom because that goes back to a 10 by 10 window, or in this case it looks more like an 8 by 10 or something close to that. But I'm going to keep zooming out until I see that flat line that's right here. And it's 7.37 for our x value. 7.37 is the length, width, and height of the original cube. And we're done.